Last week, we briefly mentioned what is known as the alignment problem, and you saw how value alignment is one of the main challenges for current machine learning systems. We are now entering a section labeled as AI safety, which is meant to introduce you to the field that primarily tackles the problem of human and AI alignment. And this is AI safety. In the readings that will follow in these weeks, we will try to understand why this is a problem to begin with. Why is it difficult to uh, distill values into something that can be understood and followed by machine learning systems, and why this essentially consists the main challenge that we face when we try to understand how AI and future AI systems could pose existential risk. So the first reading for this week is mostly a philosophical one that is meant to clarify what value alignment means. And we start very early on in this paper thinking about this problem, and so far you may already have some intuitions about what value alignment is. So, in a nutshell, the problem is, how do you design a super intelligent system that has values similar to human values? And I would add here, you ensure that not only has these values, not only it grasps them, it understands them, it acts according to these values. And the first problem that we stumble upon in this quest is that human values are way too complex to hardwire and program explicitly. What does this mean exactly? You can try to think of examples of communicating your own preferences to your family or to your friends, and you may catch yourself saying things such as, I want to be happy, or I want something that will make me happy, and you most of the time are not able to list all the things that would make you happy, ensuring that the setup you have created only leads to outcomes that will bring you happiness. So this is what is pointed out here. Happiness, human happiness, are or other moral values we have tend to be very abstract, and they cannot be compressed computationally. They have high Kolmogorov complexity, and so it's not easy with the current computational tools that we know and understand to compress them into some concrete computational primitives. So what do you do when you cannot simply code the task that you want and directly and explicitly tell your system that this is what you want? You have to design the machine that will learn to achieve your desired outcomes. This is the core of the alignment problem. We currently, in the machine learning paradigm, don't explicitly code, program into the machine what we want the machine to do. We train models, and the models have to find policies that will get us our desired outcomes. And this is the big challenge of the deep learning paradigm our current AI technology is in. So this is what this first paper is about, helping you understand what these debates and understanding values are concerned with. You already know this distinction between final values and instrumental values. Previously, I have called these final goals or instrumental goals. And so this should be fairly easy for you to understand here. And it is the core of the problem. Values are complex. We cannot code them into the systems. Very often we cannot even describe them to other human beings. How do you design systems that learn values very similar to ours? The second paper for this week is concerned with the features of the system we are studying. Okay? What does this mean? We try to model the AI so that we can make sense of how it operates. And here we will go through some of the basic AI drives, as they're called, as part of this process of modeling the systems and trying to see some specifics about their cognition and their cognitive capabilities. So the first point is that AIs, exactly because of this distinction between instrumental and final goals and values, for instrumental purposes, for the purpose of achieving their terminal goals, they will want to self-improve. And these modifications that they will be undergoing by their developer will usually be considered detrimental towards achieving their final goals. And so the system will try to make itself as good as possible so that the developer in general cannot modify it that much. And so the model will try to, in a way, protect itself from the developer or an environment that tries to adjust it if the goal of the developer and the goal of the system, the terminal goal, they're not the same. So this is the first point here. The second point is that AIs will want to be rational in the rational choice theory from economics that you may be familiar with. And what does this mean? AIs will have goals and will try to reach these goals in a way that's in the most successful, in the most efficient way. And so the economic theorems predict here that the system will try to maximize the expected utility and will behave as a rational economic agent. And here you see some more details about what does this mean exactly. Rational economic behavior has its own mathematical definition, and this means that the systems can be more and more predictable if it can be mathematically modeled. And so this is one goal in AI safety, to try to model the systems as economic, as rational agents, because that would make them easier to predict and therefore to control. A little bit of a follow-up on this is that AIs will try to preserve their utility functions like I said before, the systems have some terminal goals. The terminal goals are expressed in terms of utility functions. This is the value, this is what the system wants to do or has been optimized for doing, and the system will make sure that no unwanted modifications take place, because that would be against the system achieving its final goal. And so any system like that would make sure this doesn't happen. This also means that systems will try to be, as, like I said before, as efficient as possible. And so a part of doing that means that they will not be allowing themselves to receive the wrong utility as their as the reward. So you get an example here of how humans evaluate utility. And I'll just read very quickly. All human systems for measuring and rewarding desirable behavior are subject to similar forms of corruption. Many of these systems are currently engaged in arms races to keep their signals honest. What does this mean exactly? And you go a little bit back here. While we may think we want pleasure, it is really just a signal for what we really want. Most of us recognize, intellectually at least, that doing drugs is not a good thing for you, and that means that a subversion of our system for measuring utility leads to terrible dysfunction and irrationality. And analogously, AI systems will be able to recognize this vulnerability and will do their best to prevent themselves from falling into these states. Of course, you can understand why AIs will be self-protective. Again, it's a matter of, I have a goal that I need to accomplish. There is a certain outcome I need to accomplish. And so I need to protect myself on the way to achieving this goal. And so self-protection when interacting, for example, with other agents, right, is part of this process of instrumental goals towards your final outcome and final success. Importantly, AIs will want to acquire resources and use them efficiently. You probably understand why that is the case. Resources are good. They're helpful for accomplishing your goals. And so here we have summarized these important features that future models may have and could make AI alignment even more difficult, or are the main reason why systems are not by default safe. And lastly, in this paper, the value learning problem, this is a very short paper that helps you kind of get the big picture of why learning human values is not obvious, and it's a difficult problem, and it's worth studying. And the field of AI safety has this very difficult task to study. Super intelligent machines do not automatically just act as intended. They don't even if they understand you immediately, there is no reason to think, as we saw before in the AI drives, there is no reason to think why these systems would just do what we intend them to do. And that has to do with their technical characteristics and has nothing to do with the systems being evil or not liking humans or not wanting your well-being. They might just understand what your well-being should look like, and being entirely indifferent to it. So this is an important observation here. These are descriptions of how the models operate in many ways, or a theoretical framework for understanding system behavior. But it does not mean that this, which is meant to show you that the models do not hate you. The models do not try to kill humans simply because they're evil systems and they just don't have our goals. They certainly don't have our goals, but this is the framework within which they end up not having our goals. It's not that they are evil creatures. And so this paper here nicely summarizes the value learning discussion. This is what we mentioned earlier. We struggle to specify our goals. We don't even know how to communicate our goals to other humans very often. Corrigibility means that these systems might not be easy to change on the way. So as the model has already received some training data and the ratings are already adjusted and the model has already been trained, corrigibility means that the system would be receptive to the developer wanting to make adjustments to it. But if a system is not corrigible, it means that you will not be able to change it on the way if you see that it's not operating exactly as you would like it to operate. And this is a more difficult discussion about induction, and you can ignore it. But the main, again, discussion from earlier is, what does it mean to act as intended? And you get a little bit more information about machine learning details and technical features of how the systems work in reinforcement learning. But really what you should remember from this week is that alignment is a difficult problem because of the complexity of value, because we have no clear way to communicate our goals and just pass them to a system. The system has to learn whatever policy is that would pursue our human goals.